Okay. Hi, Geometry Pals. This is your teacher, Mrs. Smith, with a video lesson on 10.7 areas of circles and sectors. In this lesson, we're going to find the areas of circles, sectors, and segments of circles. I won't make you keep looking at me. I'm just excited about this new video app I'm trying, and it includes a picture of me. So I just wanted to try that out, but I will get rid of it. There we go. Okay, so in this lesson, we're going to find areas, circles, sectors, and segments of circles. So first thing we're going to do is areas of circles. To find the area of a circle, you need the radius of the circle, square it, multiply it by pi, and that's your area. So the first problem asks a nice, what is the area of the circle? But they give the diameter instead of the radius. So if our diameter is 32 feet, remember there are two radius in a diameter, or radii. Oops, I wrote 22. It's supposed to be 32. So the radius is 16, right? The radius equals 16. And so for our area of a circle, area is pi r squared. Hopefully this is nothing new and you remember this from middle school, or I think they even do it in algebra. Let's just plug in 16 for our radius. And that is 256. So the area is 256 pi feet squared. So for circles, a lot of times because of pi, they either say leave in terms of pi or round to the nearest tenth. If it doesn't say, you can do either. I prefer to leave it in terms of pi just because then you don't always need a decimal. But if you do, use the pi button. Don't use 3.14 unless it specifically says to. So in this case, if it did say maybe round to the nearest tenth, you would do 256 times pi, and that would be 804.2477, so 0.2 feet squared. So either one. So try this next one on your own. If you would just want practice with finding the area of a circle. In the book, they had a picture of a wrestling region, and there was a guy wrestling and everything, but literally it was just a circle with a 42-foot diameter. I know that doesn't look like a circle, but imagine like this is like a 3D, and there are people wrestling on this circle. Okay, that's what the book looked like. Okay, so solve the area of this wrestling region. So push pause, and then try this on your own, and then check back. Okay, so hopefully you got 441 pi feet squared or 1385.4 feet squared. You had to divide 42 by 2 to get the radius of 21. All right, moving on. The area of a sector. So sector is going to be a piece of your circle, almost like just, it's easiest to think of this as like pizza slices or a part of a pizza. But and that area is just going to be the percent of the circle. And we can figure out the percent of the circle using the 360 degrees. And so if you find the measure of your central angle between the 2 points on your sector and the center of the circle, and then you can divide that by 360 to figure out the proportion of the circle that your sector is, and then multiply that by the area, right? So if it was a semicircle, right, it would be half, right? Because the central angle would be 180 degrees. 180 divided by 360 is 1/2. So half the circle would just be half the area, right? So that's kind of how that works. It's just like what we did for the arc length. Okay, so let's look at this first problem. This says, what's the area of the sector GPH? So here we have GPH, and where P is the center. They're telling us that this arc length is measure is 72 degrees. So that means this is 72 degrees. So our area of the measure of our angle, our sector, is 72, and that's divided by 360 to get the proportion of the whole circle, right? And then we can multiply by pi r squared, where our r is 15. It says leave your answer in terms of pi. So this is going to be 72 over 360 times 15 squared pi. And we just have to do this here. And you can do that in your calculator, especially 15 squared. You don't need to memorize that. So 72, I would do 17 times 15 squared divided by 360. In your calculator, you get 45. So this is 45 pi. And then my units are area, so centimeters squared. So 45 pi centimeters squared. Okay, so the key is just figuring out what the measure of the central angle of your sector is, and then dividing that by 360 to get the proportion of the whole circle, and then just multiply that by the area. Okay, so press pause and try this next one on your own, and then check back for the solution. I'll leave this up for you to press pause. Press pause. Okay, here's the solution here. Hopefully you got 2 pi inches squared. For this one, I just kind of, instead of putting it in my calculator, this one you can do by hand. You can easily see that 45 is half of 90. So there's 2 here. 1, 2, 3, 4, 5, 6, 7, 8. This is 1/8 of the circle. So I change that to 1/8. 4 squared is 16. So 16 divided by 8 is 2. So our answer is 2 pi inches squared. All right, moving on. So we've gone area of the whole circle, then area of a sector, and now the last thing we're going to do is area of a segment, which is this piece here. So it's kind of, this is called, I don't actually know if we know the vocabulary of this yet, but this is called a chord. It's like a line that goes through the circle that doesn't cut through the center. If it cuts through the center, it's a diameter. This is just any other line that goes through 2 points on the circle. And then the area of that is the segment. And how we figure that out is, right, we know the area of a sector. We just learned that now. And then if you cut out this triangle, right, what you're left with is the segment. So that's what you can see in this picture here. We get the area of the sector, and then figure out what the area of this triangle is here, and then subtract it out. That's what this is here, minus. So it's area of sector minus the area of the triangle with the same central angle, and then what's left is the area of a segment. And usually I think of this as like pizza crust. So if you have, like, it's a little bit easier to think of, actually that's not a great one. If it was 1/8. This one's a little big. You wouldn't think of a pizza slice, but right, if we had the whole area of the whole sector is the whole piece of pizza, right, and then the triangle is just the toppings part, and then the segment is your crust. So it's kind of like pizza slice minus, what would you call that part? Pizza? Toppings part equals crust. That's one way to think about it. Okay, so let's try a problem with this. What is the area of the shaded segment shown at the below? It doesn't make sense. How about shown below? Round your answer to the nearest tenth. Okay, so here we have a segment, and this one actually looks like pizza crust, right? So what we're going to do is take our area of a segment, which is, or let's just do it like this. Okay, area of segment minus area, let's change the color for that. Of triangle equals the crust, or the, what's this word? Oh, sector. Sorry, I'm like, I have my vocabulary wrong. Sorry. Area of the sector, that's the purple. Area of the triangle is the toppings part, and then we're left with the segment, which is the crust. Okay, so let's start with the area of the sector. That is going to be the proportion of the triangle this is, so 60 over 360. That's our proportion, and then we need the area of the circle, which is pi r squared, and our radius is 18. Then we're going to subtract the area of this triangle, which is has 60 degrees, and this is 18. Okay, so what we're doing here is, get some nice trig in here. This is 60 degrees. So if we do it, cut a perpendicular line through this, right, and we know that this is 18, then And this has to be 30 because we're cutting that in half. So this has to be 90. So this is a 30, 60, 90 triangle. And then this is 9 because we cut this in half. And so that means this here is 9 root 3. So the area of the triangle is 1/2 base times height, where my base is 18 and my height is 9 root 3. Lovely, right? That's why we're rounding to the nearest 10th. Okay, and that's going to be our answer. So let's first do this one. This goes in, we can do this with a calculator because we do 18 squared, but I do like to just cancel this, right? We know that this goes in 6 times. So this is 1/6 of the circle. And then 18 squared, this is going to be, let's even just do pi times 18 squared divided by 6. So this is going to be 169.6. Okay. 169.65. I'm going to do to the hundredths just to make sure my rounding to the nearest tenth is more accurate, but you don't have to do that. You can just keep it tenths. And then here we're doing this math. We're subtracting. Let's move this down. 1/2 times 18, that's 9. And then 9 times 9 is 81. 81 root 3. So 81 square root 3 is 140.30. So we just have to subtract those. 169.65 minus 140.3, and we get 29.35, which will round to 4. And this is units, inches squared. So the crust on this piece of pizza that's 1/6 of the whole pizza is 29.4 inches squared. That's how much pizza we're eating. Okay, so it's a little bit complicated. Just take it piece by piece. Just think whole pizza, whole slice of pizza, sector, triangles, the part with just the toppings on it, and then figure out this area of that triangle, subtract that from the sector, and you're left with the crust, which we call segment. Okay, so try that on your own here. What's the area of this segment shown at the below? Why did I write that? Shown below. Round your answer to the nearest tenth. So try this one. I will, actually I'll leave this both up so you can see it. Okay, press pause and try this on your own and check back with the answer. All right, and hopefully you got 4.6 meters squared. The sector was 1/4, right? 90 divided by 360 is 1/4, and then 4 squared is 16, but the 4 on the bottom cancels with 1 on top, so it's just 4 pi. And then 1/2 of 4 is 2. 2 times 4 is 8, so you can do 4 pi minus 8. If it's asked for the exact answer, you would have to write, you would just leave that. Sometimes it does. But this asks for the nearest tenth, so just put that in your calculator, and this is what you get, and this changes that 5 to a 6. So it's 4.6 meters squared. Okay, and here is your homework that is due on Monday. So please try this on your own and email me if you have any questions. Okay, let me see if I can put my face back up. Maybe not. Okay, that's probably for the best. All right, bye.